Hey guys, it's Ferdinand here. Do you ever wonder how to do the programming code of the power on off LED of my Arduino HMI project? What does those blink means? Slow blinking and fast blinking. Well, this video is about the modification and improving the man-machine interface, the MMI of LED1 to communicate to the users. Well, I got you in this video. But first thing first, this is the Arduino SMI project. Our objective here is to make our power amplifier front panel looks better, a real DIY stuff, a customized displaying that suit our personal taste. The Arduino SMI with the word SMI, it means human machine interface. You got it, guys. For now, let's focus on the program code of the Arduino HMI, how we will instruct the Arduino Uno to perform this blinking, and let's start with my PowerPoint presentation. So guys, sit back and relax, get your favorite drink, get some notes if needed, and enjoy the presentation. Here you go, guys. And here is my presentation entitled Arduino HMI project. And our main topic is the code modify for number one, the LED1 MMI or man-machine interface. Number two is SW1 press and hold. Number three is the active and standby the LED1 blinks. And again, your story with the YouTube channel DR100W Concept Project, and this was made in February 10, 2025. Let me go to the next slides and welcome you back to the project Arduino HMI MMI LED program code modification. Let's go on what we can have an expectation in this video presentation is a DIY learning, implementing the wild idea. What's those wild idea mean? Later on, we can see that. Refresh our mind of the Arduino LED1 connection, timing diagram for switch SW1 versus the LED1, how to blink LED1, what is the logic pattern, is a bench test with the OSC 482H, the virtual oscilloscope from Lotto, and enjoy the videos. So let's refresh our understanding about SW1 and also the LED1. So the LED is connected at pin 13 while the switch is connected at pin 7 of the Arduino pin connection. And this is the schematic diagram. You can see here, this is the switch at pin 7 and the LED at pin 13. And this is the waveform diagram for the switch, and that's for the LED. So what it meant by that is that if we take a look at the initial state in here, where there is LED off, switch 1 is logic 1, and when you press it in here, you can see the D bounce in here. That's the emphasis of D bounce. Then release the switch and immediately LED1 will turn on. Just turn on in here. This sign in here is meant to say is predetermined or undefined time. It could be 1 hour, maybe 3 hours, 2 minutes, 5 seconds, or whatever. And then after that, you press again SW1. Again, there is a debounce in here. And once you release it, the LED will turn off. That's the basic idea that we have done so far in the previous programming. And if we're going to blink the LED, it's going to be like this. So press SW1 in here, and the original without blinking is like this. Just go straight, logic 1, and the LED just turn on. But if you want to blink the LED, what we wanted to do is a series of on and off, as you can see in here. This means to say slow blinking. This one is a fast blinking. And if we go to the next page, this is what we can see. Like for the sake of understanding, this length or the time is about 70 millisecond. Very fast. I cannot even think of 70 millisecond. And also, this turn on is 70 millisecond. This turn off is 70 milliseconds as well. So this is slower blinking, but this one in here is a fast blinking. As you can see that this is 70 millisecond, this is 30 millisecond, and you can see it's a series of on and off. But this one in here, which is just go straight at logic 1, and we have a delay of 100 millisecond. It's longer than 70 or 30 millisecond. And before I go to the next page, I put something in here. It says easy right there. Do you agree with me, guys? If not, let me know on the comment below. What I would like to know is that are you with me? And where are you watching this video right now? Let me know on the comment below. So let's go to the next page. So this is the real response of the switch and the LED. So this yellow one is the switch response, and this blue one is the LED response. And we can see that when I press the switch in here for the turning on the LED, and the LED1 will go into blinks, like fast blinking, take a break, and then it takes another fast blinking in here, like a series of 5 blinks. And then take a break in here, the LED is off in here, and then it will going to turn on in here. Again, at GND level, the LED is not lighted, and at the high level or logic 1, it is the LED is lighted. So you can see in here that this is turned on for sometimes, and then I press again SW1, which means to say that I wanted to turn it off right now. This is going to the active mode. I press once again, and it goes into the standby mode. So what it says is that when the LED is turned off, like slow blinking in here, and then we got also fast blinking in here, and then there is a 2 times blink, or I can say this is a wink, and that's the whole process. From here, then the LED is off. So press SW1 in the standby mode. It will go to the active mode with a series of blinking LED, and then press once again SW1. It goes into a kind of slow blinking, then fast blinking, then blink twice. If you can see right here, this kind of blinking is a kind of communication via your amplifier to the user or to you, which means to say that like when you press SW1 in here, just like your amplifier say, all right, I got your command. All right, I'm going to turn it right now. Sounds like this with a fast blinking. And when you want to turn it off, in here, just like slow blinking, as I say, oh no, oh gosh, you want to turn it off right now? Okay, I'll do that. And then take a break. All right, here you go. And here, there you are. I'm off. So that's how the light communications with the LED is communicating to you right now. That's my concept anyway. I don't know, guys, if you agree with me or not. Again, just let me know in the comment below. Let's go to the next page. And what I'm showing it in here, this is the real world waveform of SW1. And you can see that small stuff in there. That's the debounce for the switch. It is can captured by the OSC482 oscilloscope. And there is a blink in here, like turn on here, turn off, turn on, turn off. So turn on 1, 2, 3, 4, 5. It turn on 5 times faster, and then before it goes to fully turn on the LED. So that's again a kind of communication by your amplifier when you turn it on. And then if I wanted to get the measurement again using the OSC482, so like I press SW1 with about 552 millisecond. So I hold the SW1 for like half a second, and then once I release it, the LED will blink 5 times. So 1, 2, 3, 4, 5, very, very fast. And then from that blink, it will goes to that the timing, and it will turn on. So the timing from B to C, that's about 1.5 seconds in here. So after I release the switch, then the LED will turn on 1.5 seconds later. It means to say your amplifier will turn on 1.5 seconds after I press SW1. Pretty easy, right? I really hope you're following me right now, because this is not really about designing the CDOM, designing the wattage of the resistors, or trial and error on the capacitors, but it's all about the timing diagrams of the LED, which is really different from the hardware point of view of an analog power amplifier. Well, let's just go on to the next page. What is this? Yeah, I mentioned already, so 1.5 seconds. And I'm emphasizing once again about the debounce in here, which is the real characteristic of a mechanical switch. Really, the OSC482 is a very powerful oscilloscope that it can really detect the real world response of a switch. This is the debounce. And I can do lots of measurement in here, like the timing diagram, and how what is the turn on time. As you know, guys, in episode 2 of programming, when I was in my hometown at about 1,500 meters above sea level in Baguio City, the Philippines, I mentioned about the OSC 482 or OSC F4, which is I give a little time to understand about the timing diagram of the Arduino, how precise is the delay, like for example, delay of 30 millisecond in here. And it shows in here that the delay of this one is really 31 millisecond or 30 millisecond. It's very, very close. So I know that in programming, I really need a precise delay in order for me to make a good response of the LEDs. So I put the video number 2 in our series of the AMPduino HMI project to understand about the delays in microcontroller or the Arduino Uno. And that's the whole point. I'm putting it right now and recording back the episode number 2. Let's go ahead and what I'm by the way, what I'm trying to show in here is that the turn on time is 31 millisecond, the real response in the real world, while my program it says delay 30 milliseconds. So there's a little bit of 1 millisecond difference, and that could be a measurement error. And in the second page, this is the delay of the off time, wherein that is 0.07 seconds, or that is about 70 millisecond. Exactly, this is my command, and this is what I read in a real world response. On the next page, I show you my command or instructions using the for next command. And as I'm saying that what I read in here to turn on the LED is 31 millisecond, and my instruction is a delay of 30 millisecond. And the delay of low in here, this is the low, means LED is off, is 70 milliseconds. And you can see in here that this is the off, and this is 70 millisecond. So this means to say that I am going to blink the LED 5 times. This for instruction in here, it means to say that it will going to repeat this instruction 5 times, from 0, 1, 2, 3, 4. This instruction means to say that I initialize j is a variable, initialize that into 0, and I'm going to increase the value of j from 0, and I will do it repeatedly if j is less than 5. That means to say this instruction will repeat until j value is 4. And j++ means this is the instruction to increase the j variable from 0, 1, 2, 3, 4. That's the main meaning of this instruction. Alright guys, I hope you're really following me. This is something new to people who do not know so much about instruction or programming. But I think you can able to catch it up. Just try to understand and go walk with me side by side. Yeah, I basically mentioned it already in here. I don't have to repeat these slides anymore. And let's go to this delay in here. So there is like 1, 2, 3, 4, 5. So that is the 5 turn on and turn off 5 times, as I mentioned to you earlier on the previous page. And this delay in here, is about 1 second. So this the lane here is says that turn off the LED or put the LED into low. So this is the low for 1000 millisecond. So 1000 millisecond is 1 second. So this is the real world response of a delay of 1000 millisecond, which is equivalent to 1 second. Let's go to the next page, and this is a kind of delays that I have put down into the active mode. So when it goes into the active mode, it will go to a series of blinking LEDs, like what we can see in here in the real world response. This is it, guys. Take a look at it once again. And then when we are going to turn it off, I'm going to press SW1 in here, and they're gonna be like a slow blinking in here, like, all right, you want to turn it off right now? Okay, just like that. This is the real world response, and that's really the meaning of those blinking LEDs. And this is actually the implementation of the program code. Um, it's pretty cool if you can get my program code so that you can really see those kinds of a command that I put in there so you can understand better. And if I'm going to go to the power on and power off, I mean, this is the power off summary of the instruction that I made. This one in here, there is a delay in there. That is the delay, 800 millisecond, and then there is a delay of 500 millisecond on and off, and the other one is there you go. So the whole series of this real world response is are those the command that I have implemented in the program. And I'm saying that it's really good if you can see the program, the real code that I have written, so that it will be make sense to you rather than just a partial one. I'm just only putting right here and emphasizing those modification I have done so far, so that you can understand what are those blinks LED mean and how they are instructed and executed in the real world. So I think the real thing is that you need to see those command in my code. What I have here right now is additional modification on the LED, like in this standby mode, the LED will go into blink every 8 seconds, and also in the something is wrong with my PowerPoint. This is the problem with copy and paste. So standby mode and sorry for that. So in the standby mode, it blinks every 8 seconds. So that means to say that it's just like wake up every 8 seconds, and I'm saying, "Hey, I'm still here," and sounds like that. And in this, my spelling is even wrong. This is active mode, and then it winks every 8 seconds. So actually, the LED is turned on, and then it winks every 8 seconds. So I'm not showing here the modification right now, but in the code, it's in there. And if you can think of something how to do that, that would be really, really cool that you understand how program works. And for the SW1, press and hold, I also make the modification, but I suggesting here that it's better to see the code to see the logic and the modification I have done. It's a little bit complex because the way my mind runs, it's not as simple as the others. So you can see from my programming, that's exactly the reflection of what my mind is really thinking, the kind of logic inside the nerve of my brain. And then what else I can say is that the server code really is what really my mind can understand. There are better code using a professional one like the millis instruction, wherein you don't need to make use of the delay instead of like a kind of interrupts or a better timing, and that's a kind of instruction that can be implemented. And there is also a library I searched from the internet manually. I did not use AI to search for it, called the Easy Button Library for the SW1, which is mean pretty cool actually. It is done by others, but I don't want to use them because it's done by others. Normally, I don't copy and paste, but it's nice to explore it. I tried it and it's pretty cool. And I would say that using Millis and Easy Button Library, they're really pretty easy. Easy, I mean, but I'm saying that I prefer my own code. And the things that I'd like to end right now is that enjoy your journey to audio amplifier build with the programming with the Arduino skets and level up your DIY know-how with the Arduino program. That means to say now, guys, that I'm going to end this video. It's a little bit long videos, but I hope it gives you something that can help you to understand what I'm doing in here on the programming for the AMPduino HMI project. Well, well, there's a cheers in there. It was delayed. That was a delay of about a 2000 millisecond. And what I'm doing it right now actually is building a new bands of shield for the Arduino MMM. That is the Arduino My Music Mate, wherein I have here already. Those are the captures that I had initially to make a new shield. I would say make a new shield and a new brands, a new design of man-machine interface, I should say. Well, I'm going to publish all of those things and hope you're going to watch them all. And if you are really interested, let me know in the comment below or you can contact me directly and let's see if we can go for the concept of DIT. As what I'm saying in here, this is the one, the concept from DIY to DIT so that I will not be alone and we can build that kind of automation testing process. I would like to walk with you guys, whoever it is, and especially for ladies, you are more than welcome. Bye for now, guys. Bye for now.